according to the question we have here, it says that we should find the oxidation number of manganese in potassium permanganate. What we need to do first is to know the formula for potassium permanganate, which is KMnO4. That is potassium permanganate, KMnO4. We are asked to find the oxidation number of this manganese here. So how do we go about it? We need to know the oxidation number of potassium and that of the oxygen. Oxygen number of potassium is +1 and that of the oxygen is -2. So we have it +1. So let's add everything together. And don't forget, this is in a compound, it's a compound. So the sum of oxidation number of all the atoms in their compound state is equal to 0. So plus Mn. So we are adding the oxygen number now together. We are looking for this. That is why I write the symbol back. Plus oxygen number of oxygen is -2 multiplied by 4. So we have 4 of the oxygen there. Everything will be equal to 0. Don't forget, I said it earlier. When you sum up all the oxygen number of all the atom in the compound together to be equal to 0. So we move further to have +1 plus manganese plus -2 times 4 is -8 will be equal to 0. Plus times minus here we have +1 plus manganese. Plus times minus is -8 equal to 0. We're having, let's collect the like terms now. Manganese -8. There's +1 here. +1 equal to 0. So we have manganese now will be equal -8 plus 1, that's -7 equal to 0. So taking this -7 to this side become +7. Manganese now will be equal to +7. So the oxidation number of manganese in KMnO4 is +7. Stay tuned for another one. Water for tank supply is chlorinated to make it free from, and the options are A, bad odor, B, bacteria, C, temporary hardness, and D, permanent hardness. Now, I want you to take note that the answer to that question is B. That is, in order for it to be free from bacteria, that is the answer to that question. I want you to have this at the back of your mind, that when you check through your book, you will see that the purpose of adding chlorine to water to be supplied to township is for chlorine to kill the germs in the water. And among the options we have there, the bacteria alone is the germs that we have among the options. Now, another set of things that are added, or chemicals that are added to water to be supplied to township, I'm going to take note of them for you now, which I think it might be useful when you want to answer a question in an exam. It can be from that angle as well. When water is being supplied for treatment, the first set of chemical to be added to it is potash alum and sodium aluminate. Potash alum is with this formula. This is potash alum, KAlSO4, 2, and sodium aluminate 3 has this formula, NaAlO2, NaAlO2. Now, the purpose of supplying or adding these two chemicals is to coagulate or flocculate the dirty particles that are coming alongside with the water to be treated for township supply. That is the purpose of adding those two chemicals. That is potash alum and sodium aluminate 3. Another set of chemical that needs to be added to water is calcium oxide or calcium hydroxide. You can agree with me that these two are base or an alkali, and the purpose of adding the two is to reduce the acidity of that water. We have the calcium hydroxide, that's this, and calcium hydroxide. This is the calcium hydroxide. It is added in order to reduce the acidity of that water, and that is the purpose of adding it. Another chemical that is added to water to be supplied to township are iodine and fluorine. Iodine and fluorine. The purpose of adding iodine and fluorine is to prevent goiter and tooth decay, so that water will not be the one that will be causing goiter or tooth decay for those people that will consume it. That's the purpose of adding different type of those chemicals. Thank you. How many lone pair of electrons are there on the central atom of water molecule? Water molecule have this symbol, which is H2O. The central atom in water molecule is oxygen. That's the central atom that we have there, which is oxygen. So now let's look at the structure then, as we are going to bring out the number of lone pair. Now, for the oxygen, if you want to draw the electronic configuration of oxygen, don't forget that if you count on the periodic table, oxygen is found in group 6. Oxygen is found in group 6. So we are going to have it to be, this periodic table, the structure will be like this. 1, 2, 3, 4, 5, 6. So that is oxygen atom. This is oxygen atom. That is the structure of oxygen atom. Now, for that hydrogen to come in now, one hydrogen will come in here. Hydrogen. Another hydrogen will come in here. Hydrogen. You can see H2. We have 2 hydrogen now. That's H2O. And we have only one oxygen attaching to it. Now, if you look at it very well, you will see that there are some of the electrons that we have at the outermost shell here that are not attached to anything at all. These are called lone pairs. Lone pairs. This is another lone pair. So how many lone pairs do you have? You have 2 lone pairs. You can see they are alone. They are not attached to anything. So we have 2 lone pair of electron in the central atom. Don't forget, I've told you earlier that oxygen is the central atom of water, which is H2O. So that's the answer to that question. 4 elements PQRS have 1, 2, 3, 7 electrons in their outermost shell, respectively. Which element is unlikely to be a metal? Now, if you look at the question very well, we are told that those elements have their electron in their outermost shell. And I want you to take note of this. Quickly, I'm going to draw the periodic table for you of the first 20 elements, which I'm having hydrogen here, I'm having helium here. I have to make sure that it is 8, 1, 2, 3, 4, 5, 6, 7, and then 8. That is, I put it 0. These are the group that we have there. Now, from this group, you can be able to get a lot of information. Hydrogen, helium, we're having lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Now, this is the first 20 elements that we have on the periodic table. Now, in the outermost shell, the number of groups they belong to can be used to determine the number of electrons you are going to find in the outermost shell. So now, when we have 1, which means that all the elements here, the electron you are going to find in the outermost shell will be 1. And these are called the alkali metal group. Alkali metal group. And we have another one which is 2, which is also metals. These are metals too, which is what? They are called the alkali earth metal. Alkali earth metal group. This group 3 too, they are also metals. They are in group 3. The number of electrons you are going to find in the outermost shell is also 3. They are also metals too. But the remaining one, which is having 7 electrons in the outermost shell, which is that of group 7, those are the halogens. And all of us know that halogens are non-metals. Non-metals, because we have chlorine to be chlorine in its ion form will be Cl minus, fluorine F minus. So they are having 7 electrons in the outermost shell, where when they accept just 1 electron to their cell, they are going to attain the so-called octet structure. So the answer to the question is the electron with 7 electron. The atom with 7 electron is the one that is non-metal. Thank you.